Okay, number 3, we're going to rewrite the fraction as a single simplified fraction with a rationalized denominator. No perfect squares. So that's our first step, is to rewrite this using perfect squares. So our numerator, 6 is not a perfect square, and it can't be broken down into any, it's just 2 times 3. So we're going to leave it. But 13 p's, so if I have p squared 6 times, I think that's 6, 2, 4, 6, 8, 10, 12, and I'm going to have 1 left over. And then on the denominator, 2 is not a perfect square, but now I have 7 p's. So I just broke them down into squares because then I can take the square root. So p squared, the square root of that is just p. So I'm going to write down here. So now outside the square root I have 1, 2, 3, 4, 5, 6 p's on the numerator. And then inside I still have 6 with 1 p. And on the denominator, I have 1, 2, 3 p's. And then on the denominator, I still have a 2 and a p inside. So this is something we can simplify. Okay, I have 6 p's and 3 p's. So if I divide those, if you need to write it out, you can. I have 6 on the numerator. And on the denominator I have 3. So if those cancel out, I'm left with 3 on the numerator and 0 on the denominator. Okay, so this is where we have to do the rationalized denominator. We can't have a square root on the denominator. So to get rid of that, you multiply by itself. So I'm going to multiply the denominator by 2p and the numerator by the square root of 2p. So let's write out what happens when we do that. On the numerator, I still have 3 p's out here. And then when we multiply square roots, we multiply the inside and we put them under 1 square root. So 6 times 2 is 12. P times p is p squared. And then on the numerator, denominator, at 2 times 2, which is 4, p times p, which is p squared. And now it's kind of like we're back up here in step 1. I'm going to rewrite my perfect squares. So underneath here, I do have a perfect square. I have 12, which is 4 times 3. 4 is a perfect square. And now I have p squared, which is a perfect square. And on the denominator, I have 4, which is a perfect square, and p squared, which is a perfect square. So I'll come down here. Let's look at my numerator. I have the square root of 4, which is 2, so that comes out. And then I have the square root of p squared, which is p. So all that's left in my radical is this 3. And then on the denominator, I have the square root of 4, which is 2, and then the square root of p squared, which is p. So notice how now there's not a radical. We just rationalized, that's what we just did. But now we have some simplifying to do. So this 2 cancels with this 2, this p cancels with this p, and all we're left with is p cubed square root of 3. And that's our answer that we would put into derivative.